Okay, this is Algebra 2, Chapter 3, Section 4. Just a quick look at the vocabulary again. I covered a whole video on the vocabulary. We've got our feasible region again is the shaded area. The constraints are the actual inequalities here. Bounded means that those inequalities, when you graph them, form lines, and those lines bound or border the shaded region or our feasible region. And the last word we had were vertices, and the vertices are these blue points, which are our corner points of our feasible region. So let's make sure we know those vocabulary words, because whenever I start talking about them, I don't want to lose you over vocabulary. So here's an example of a basic problem for this type in the book. We want to find the coordinates of the vertices, find the maximum and minimum values of the function for the region bounded by, and then here are our constraints. So the very first problem we have is none of these are written in y equals mx plus b form. So we've got to rewrite them all in y equals mx plus b form. So the first one's pretty easy. We subtract the 2x from one side, and so we're going to subtract the 2x from the other side. So this becomes y is greater than or equal to negative 2x plus 3. Second one's a little bit more difficult, so let me work that one out. So I'm going to have to add x to the other side, so I'm going to add x over here. So that one's going to become 3y. Is going to be less than or equal to x plus 9, and then I'm going to have to divide everything by 3. And when I say everything, I mean everything. So then y is going to be less than or equal to, and that becomes 1/3 x plus 3. So I can rewrite that one up here. So y is less than or equal to 1/3 x plus 3. And then my last one down there, that one's pretty easy also, so I'm going to be subtracting 2x from both sides. So that becomes y is less than or equal to negative 2x, and it's going to be plus 10 at this time. And if you haven't noticed, we've got two lines that are parallel. One is going to be greater than and one is less than, so hopefully we're between the two. Otherwise, this is kind of, I guess you could have no answer to this. So let's go forward and see what we've got here. So let me graph the blue one in blue. So this is going to be a y-intercept of 3, so up 3. And then we've got a slope of negative 2, so down to forward 1 and up to back 1. And let me grab a blue line. Oops, that one's going to be too thick. Grab a blue line. And so up 2, go here. 2, down 2, down 2. I think I'm all lined up there. Okay, so that's my first equation graphed in blue. Let me get my second one, and I'll graph it in red. So my y-intercept is still 3. And this time I'm going up 1, forward 1, 2, 3. Up 1, forward 1, 2, 3. Up 1, forward 1, 2, 3. Go the other way, so it's down 1, back 1, 2, 3. Did I go too far? 1, 2, 3. I did go back too far. Down 1, 1, 2, 3. Down 1, 1, 2, 3. Grab an eraser real quick and get rid of, which one was it? That one. Blue point right there. And then I need a line, and it should be red. And so this one's coming through here. And then my third one I'll do in green. And so the third one has a y-intercept of 10. So we're all the way up here, right? And we're coming down 2, forward 1, down 2, forward 1, down 2, forward 1, down 2, forward 1, down 2, forward 1. And grab a green line. And put that one on the graph. Let's see. I think I'm right there. Okay. So we need to add in all of our shading and find out what this does to our shading. So if I am on the blue one, So I probably need a blue highlighter of some sort, right? Let me grab a highlighter and blue. If I plug in the point 0, 0 for the blue one, 0 would be greater than 3. That would be false. So I know I'm shading this way, right? And I could shade it all the way over here because I don't really know where I'm shading. And then the second one, the red one, let me grab pink for highlighting. If I plug in 0, is 0 less than 3. And that would be true. 0 is less than 3. So I know I'm shading down here, right? Somewhere down this area. I'm looking for the area where all these are going to cross. And the last one I did in green. So is 0 less than 10? And 0 is less than 10, so I am shading in here. So this little area here, which is now kind of black, is my end result. So let me clean that up quite a bit. And I know my area that I'm shading is this area in here. And I'm not coloring in the lines very well, so I might have to clean that up too. Go back and clean that up. Okay, so we've got the constraints. We are equal to our constraints, and we've got the shaded region in there. So now we've got to find our corner points, because our corner points are our vertices, right? Our vertices. I need to change into a pen here. So we're looking for our vertices, and those would be our corner points. So we've got one here and one here, and those are our only two corner points, because this rest of this is going on forever. So this first point is the point 0, 3. And our second point is the point 1, 2, 3, 3, 4, I believe it is. And let's double check that. So 4 is less than or equal to -6 plus 10. So that's right. Yep. So that's point 3, 4 and 0, 3. So it says find the maximum and minimum values of the function. Okay, well the minimum value, since it's going on forever negative, we're not really going to find a minimum value of this. But we can find a maximum value where it's the biggest. And it's either going to be at the point 0, 3 or at the point 3, 4. So I'm going to take that function there and grab black. And so 5x plus 4y. And I'm going to plug in 0 and 3. So that's going to be 0 plus 12, or 12. And then I'm going to take that same function, the 5x plus 4y, and I'm going to plug in the point 3, 4. So that would be 15 plus 16, and that's definitely much bigger, so that's 31. So this point 3, 4 is the maximum, and we don't really have a minimum because it goes on forever in the negative direction.